All right, so last section of the thermal energy notes. So how do we determine the thermal energy of a particular thing, or how do we determine what its caloric intake is? Like think of a candy bar, right? When you look at the back of a wrapper, you go, okay, a calorie. Well, what is a calorie? Well, a calorimeter is what we use to determine the specific heat of a substance. So a calorie is really what is the unit that we're using to determine how much a specific heat is going up or down. All right. So we use a calorimeter to determine the specific heat of a substance, how much is lost or how much is gained. All right. So heat gain is equal to heat loss. So first, take the mass and the temperature of the water are measured. Right. So you got this mass of the water and the temperature on the outside, right? That's on the outer chamber. Then they take the sample, they put it inside this inner chamber, which is then heated, right, and put inside the water. So then that change in temperature is measured for water to get the heat that it gains. So basically they take the object, stick it in there, burn it, see how much heat it gives off, right? So however many calories that it moves up that specific heat, well then that gives you how much energy is in that object. Right? So this gives heat loss, or the heat loss by that substance. So knowing its value, right, that gives us what its specific heat and how we can determine what it is. Alright, so let's start here. Right, I've got a 55.1 gram piece of metal. It's heated to a temperature of 45.1 degrees Celsius and placed into a cup containing 359 grams of water at 20 degrees Celsius. The final temperature of the water and the metal is 22.3 degrees Celsius. Alright, so what do I have to do? Well, first, how much heat energy did the water absorb? Alright, so let's figure that out. How much heat energy did it absorb? So go through my problem here, right? I know that the water was 359 grams. I know that the specific heat of water is 4.184. Okay, the temperature change went from my initial was 20, my final was 22.3, so that gives me a 3.45 Q, right? That's the amount of energy, right? So 3,450 joules. So now I've got that. So now how much heat energy does the metal release? Right? So the energy gained should be equal to the energy lost. So therefore, the metal lost a negative 3.45 times 10 to the third. So really all I got to do is take the number that I get for the energy gain and just put a negative number on it to show that that's the amount of energy lost, right? The amount of joules that were given off by that object. So if the Q is negative, it's because heat was lost, right? So it's exothermic. If the Q is positive, then that means it's endothermic. So what is the specific heat of that metal? So then I take the Q, plug it into the mass, right? So it was 55.1 grams for that piece of metal. I don't know the specific heat. That's what I'm trying to figure out. But I do know that its original temperature, its initial temperature was 45.1, and that its final temperature was 22.3. All right. So then I'm going to multiply, right, these two numbers, then divide, and that'll give me my specific heat, and I end up with it being 2.75. So the specific heat for this object, whatever this piece of metal is 2.75. So this is also another way, like maybe I don't know what a material is, and if I heat it up, I can then figure out what it is by how much energy it gives off, because most objects give off a certain amount of energy depending on what they are. So it's another way of classifying what something is. All right, heat of fusion. What is this? Right. Well, this is the quantity of heat absorbed when a specific quantity of a solid is converted to liquid at its melting point. This is called the heat of fusion. Right. So here I've got this ice cube. Right. What is the heat? What is the quantity of heat that's needed to turn that from a solid into a liquid? All right. Heat of vaporization. So this is the quantity of heat absorbed when a specific quantity of a liquid is turned from a gas or from a liquid into a gas at that boiling point. This is called the heat of vaporization. Well, that was pretty easy, right? Because, I mean, gas is turning into a vapor. All right, so here are some phase diagrams, right? So I've got my solid. So as it goes up, the temperature increases. Okay, so I get to that melting point, right? Remember, the temperature changes, so we call that's our heat of fusion, right? So how much energy is needed to turn that into a liquid? Once it gets into a liquid, then it continues to rise in temperature. Once it gets to that boiling point, okay, temperature is going to plateau. This is my heat of vaporization. Right? How much energy is needed to get that temperature for 1 mole of water to change? All right, and that's it. Okay, guys. Well, that's all the notes. All right, make sure you got them all, and we'll be checking them in class.